Hi, let's continue our discussion of control systems and look at steady state error. Okay, so if you have a control system, as we have already said, there are two kinds of response in a control system. We have the transient response and we have the steady state response. The steady state response is the response that happens after the control system has had enough time to stabilize to a particular output. Okay, and the error in the control system is given by the equation here, and I'm sure you would be able to write this equation very easily from this control system. The error is basically the difference between the output and the input, rather the opposite. It is the difference between the input and the output. It's r minus y gives you the error. And the steady state error can be calculated by using the final value theorem of the Laplace transforms. So et at t, when t starts tending to infinity, is given by this equation, which means that if you substitute the error, you get this kind of an equation. Now, to analyze steady state error, we need to understand another concept called the type of the system. Okay, so let's take a look at that. So we could write the loop gain, that is gc times g, in general as this. So it has got some zeros, it's got some poles, and it's got some poles at s equal to 0. Okay. Now the steady state error depends, or the behavior of systems depends on how many poles you have at 0. And this number n is called the type number of the system, or the type of system. So you could have a type 1 system, you could have a type 0 system, a type 1 system, a type 2 system, and so on. So what type denotes is how many poles you have at s equal to 0. Okay, so uh, in the next few videos, what we'll do is we'll take a look at steady state error due to different kinds of inputs for different types of systems.